Picture this. A fiery plume of ash and molten lava erupts from Japan's Sakurajima volcano, one of the most active volcanoes on Earth, spewing debris into the sky in a spectacle both beautiful and terrifying. In 2024 alone, Sakurajima unleashed multiple eruptions, with one event sending ash clouds over 5 kilometers into the atmosphere, grounding flights and blanketing nearby cities. But what if this wasn't just a local event? What if this single eruption could ripple across the vast Pacific, setting off a chain reaction of seismic chaos along the infamous Ring of Fire? This isn't science fiction. It asks a question geologists and seismologists are grappling with as we uncover the interconnected forces that shape our planet. The Pacific Ring of Fire isn't just a catchy name or a line on a map. It's a 40,000-kilometer arc of tectonic fury encircling the Pacific Ocean, home to over 75% of the world's active volcanoes and responsible for 90% of global earthquakes. From the Andes in South America to the Aleutian Islands in Alaska, from Japan's restless peaks to New Zealand's steaming craters, this is Earth's most volatile region. But what makes it truly fascinating and a little terrifying is how interconnected it all is. One massive quake or eruption could, in theory, nudge neighboring faults and volcanoes, potentially igniting a cascade of geological events. So let's dive into this fiery puzzle. Could one eruption really trigger a global domino effect, and if so, how? To understand the potential for cascading chain reactions, we need to get under Earth's skin, literally. The Ring of Fire is defined by tectonic plate boundaries, where massive slabs of Earth's crust grind, collide, and slide past each other. Most of the action happens at subduction zones, where one plate is forced beneath another, diving into the mantle. This process is like a cosmic pressure cooker. It melts rock into magma, fuels volcanoes, and stores energy that can unleash devastating earthquakes. Take the Cascadia subduction zone off the coast of the Pacific Northwest, for example. It's where the Juan de Fuca plate slides beneath North America, building stress that hasn't fully released in over 300 years. When it does, experts predict a magnitude 9.0 plus earthquake, potentially triggering tsunamis and shaking volcanoes awake across the region. Mount St. Helens, which famously erupted in 1980, sits in this volatile neighborhood. Could a quake here nudge nearby volcanoes like Rainier or Hood into action? The science says it's possible. The interconnectedness comes from how tectonic plates are linked like pieces of a cracked eggshell. Stress released in one area, like a massive quake in Japan, can redistribute pressure to adjacent faults or even distant ones. In 2011, the magnitude 9.0 Tohoku earthquake not only triggered a devastating tsunami, but also increased seismic activity in far-off regions, including small quakes detected in California. This stress transfer is the key to understanding how one event might spark another. Let's paint a scenario. Imagine a supervolcano like Yellowstone, while not directly on the Ring of Fire, is influenced by distant tectonic shifts. A massive quake in Chile's Andes, home to active volcanoes like Villarrica, releases stress along the Nazca Plate. This shift subtly alters pressure thousands of miles away, perhaps destabilizing faults near Yellowstone or even Iceland's volcanic systems, which are sensitive to global tectonic changes. Suddenly, a chain reaction begins. Small tremors awaken dormant volcanoes, magma chambers swell, and eruptions ripple across continents. This isn't just speculation. Historical data shows eerie coincidences. In 1991, Mount Pinatubo in the Philippines erupted catastrophically, one of the largest eruptions of the 20th century. Within weeks, Mount Hudson in Chile blew its top, and seismic activity spiked across the ring. Were these events linked? Scientists think it's plausible. A 2017 study in Nature Geoscience found that large earthquakes can trigger distant volcanic eruptions by altering pressure in magma chambers, even thousands of kilometers away. The 2004 Sumatra earthquake, for instance, may have influenced eruptions in Indonesia's Merapi volcano months later. The mechanism behind this lies in something called dynamic triggering. Unlike static stress changes, which are slow and localized, dynamic triggering involves seismic waves, ripples of energy traveling through Earth's crust, that can jostle faults and magma chambers far from the original quake. These waves are like a tap on a fragile glass. If the system is already near breaking, a little nudge can set it off. The Ring of Fire, with its dense network of faults and volcanoes, is the perfect stage for this kind of geological domino effect. If a chain reaction were to unfold, the consequences would be staggering. The Ring of Fire is home to millions of people, from bustling cities like Tokyo and Jakarta to coastal communities in Peru and Papua New Guinea. A single eruption or quake can disrupt global supply chains, as seen when the 2010 geological eruption in Iceland grounded flights across Europe. Now imagine multiple eruptions or quakes hitting in sequence, ash clouds choking air travel, tsunamis flooding ports, and infrastructure crumbling under seismic strain. The environmental impact could be just as profound. Volcanic eruptions release massive amounts of ash and gases like sulfur dioxide, which can cool the planet by reflecting sunlight. Pinatubo's 1991 eruption lowered global temperatures by about 0.5 degrees for a year. A cascade of eruptions could amplify this, disrupting agriculture and weather patterns. On the flip side, the carbon dioxide released could contribute to long-term warming, creating a complex climatic tug-of-war. But it's not all doom and gloom. The Ring of Fire's activity has shaped Earth's beauty. Think of Japan's cherry blossoms blooming beneath Mount Fuji, or the lush rainforests fed by volcanic soil in Indonesia. Understanding these connections helps us prepare. Advanced monitoring systems, like those used by the U.S. Geological Survey and Japan's Meteorological Agency, track seismic and volcanic activity in real time, giving us a fighting chance to predict and mitigate disasters. Here's the million-dollar question. Can we predict when a chain reaction might start? Short answer. Not yet, but we're getting closer. Seismologists use tools like GPS and satellite imagery to monitor tiny ground movements, while volcanologists measure gas emissions and magma chamber swelling to gauge eruption risks. Machine learning is also entering the game, analyzing vast data sets to spot patterns that humans might miss. For example, a 2023 study used AI to predict small quakes along the ring with 80% accuracy, a promising step toward forecasting larger events. Still, the complexity of Earth's systems makes precise predictions tricky. The Ring of Fire spans dozens of countries, countless faults, and hundreds of volcanoes, each with its own quirks. A quake in one spot might trigger nothing, while a smaller tremor elsewhere could be the straw that breaks the camel's back. It's like trying to predict the weather on a global scale, possible in broad strokes, but the details are maddeningly elusive. The Pacific Ring of Fire isn't just a geological hotspot. It's a reminder of how alive our planet is. Every tremor, every eruption, is a pulse in Earth's restless heartbeat. The idea of a single event sparking a global chain reaction might sound like a Hollywood blockbuster, but it's grounded in real science. The interconnectedness of tectonic plates means that no volcano or fault operates in isolation. What happens in Japan could, in theory, rattle Chile or Alaska. This interconnectedness is both a challenge and an opportunity. It pushes us to think globally about disaster preparedness, from strengthening infrastructure to improving early warning systems. It also deepens our awe for Earth's power. The same forces that threaten devastation have sculpted mountains, carved valleys, and enriched soils for millennia. The Ring of Fire is a paradox, a creator and destroyer, a force that humbles us while sparking curiosity. So, could one eruption ignite a global cascade? The answer is a cautious maybe. The Ring of Fire is a web of triggers, each waiting for the right push. As we unravel its secrets, we were not just chasing answers. We were learning to live with a planet that is always one step ahead, ready to surprise us with its fiery, unpredictable dance.